Beneath the surface of northern Brazil, not far from where the Amazon meets the sea, there is a tunnel that should not exist. It runs for 1,500 meters, branching and turning through solid earth, tall enough to stand in and wide enough to drive through. And along every wall, gouged deep into the stone, are the marks of enormous claws. These are the largest burrows any animal has ever dug, and they were not made by people. They were carved by giant ground sloths, creatures the size of hippos and elephants. For a long time, the story was simple. Slow, lumbering, primitive things swept away when the Ice Age ended and the world warmed. Almost every part of that is wrong. They were not doomed, and they were not simple. They were one of the most successful lineages the Americas ever produced, and the real reason they vanished was never the cold. To understand how wrong that story is, you have to first understand how large the truth was. Ground sloths were not a single creature. They were a dynasty. At their height, there were as many as 80 species spread across 2 entire continents, from the deserts of the north to the cold tundra of the far south, through the forests and the open plains and everything between. They were not clinging to the margins of the world. They had colonized almost every corner of it, and they came in every size imaginable. Some were no larger than a big dog, knuckle-walking through the undergrowth. Others were among the largest land mammals that have ever lived. Megatherium, the great beast of the southern plains, stood taller than a man when it reared up and rivaled an elephant in bulk. Aramatherium, its tropical cousin, may have been larger still, broaching and perhaps surpassing the size of a very large African bull elephant. Imagine that for a moment. A creature the weight of the biggest elephant alive today, covered in shaggy fur, balancing on its hind legs to strip the leaves from the crown of a tree. That was not a rare exception. That was an ordinary animal in this world. They were so abundant, and they left remains so enormous, that they were among the very first extinct creatures human beings ever recognized. Long before anyone understood deep time, before the word dinosaur had been invented, the bones of giant sloths were being pulled from the ground and puzzled over. They were so big and so strange that they helped teach us the idea that creatures could vanish from the earth entirely. The giant sloth was one of the animals that first showed us extinction was real. So set aside the picture you were handed. Forget the slow, dim, doomed creature shuffling toward its inevitable end. What actually stood in the Americas for tens of millions of years was one of the most successful groups of large mammals the hemisphere has ever known. They outnumbered. They outlasted. They outadapted nearly everything around them. While other lineages rose and fell, the sloths held their ground, century after century, across a span of time so vast it is difficult to hold in the mind. And here is where the real puzzle begins. Because a group that successful, that widespread, that endlessly adaptable is not supposed to simply disappear. Animals like this do not vanish by accident. They are not fragile. They are not waiting for one bad winter to finish them off. They are the ones that survive the bad winters, the ones still standing when the weaker lineages are gone. Everything we know about how evolution works says these animals should have been almost impossible to kill. And yet, as little as 10,000 years ago, nearly all of them were gone. Dozens of species across 2 continents wiped from the earth in what amounts to a geological instant, leaving only their small climbing cousins asleep in the treetops. Something brought down a dynasty that had ruled for an age. To understand what, you have to understand the strange gift that made them so unstoppable in the first place. It was not strength. It was slowness. The secret was metabolism. Living sloths have the slowest metabolic rate of any mammal ever measured. Not among the slowest. The slowest. The 3-toed sloth burns energy more sluggishly than a platypus, more sluggishly than an echidna, more sluggishly than the strange egg-laying mammals that science usually holds up as the slow extreme. Studies of the brown-throated sloth have found its metabolism running at somewhere between 40 and 74% of the speed of an ordinary mammal its size. It is, in the most literal sense, running at half power, and it manages its own heat in a way almost no other mammal does. Most mammals, ourselves included, are locked into a narrow band of body temperature, stray more than about 1 degree from it, and we are in trouble. A sloth thinks nothing of swinging 10 degrees across a single day. Its temperature sits low, around 30 degrees, far cooler than ours, and it drifts with the world around it. When a sloth grows cold, it does what a reptile does. It finds the sun and it basks. Warm-blooded, yes, but only loosely. Its body listens to the air around it. This is the thing that looks like a weakness and is in fact a superpower. Because an animal that burns so little fuel needs so little food. Consider the howler monkey. It is roughly the size of a 3-toed sloth. It lives in the same forests. It eats the same diet of leaves. And to stay alive, it must eat nearly 3 times as much. The sloth does the same job on a third of the groceries. In a world where food is the one thing every animal is competing for, that is an almost unfair advantage. But this is the metabolism of sloths living now. The question is whether the giants of the past shared it. And in 2025, a study found a way to ask the bones directly. When an animal grows its teeth, it locks rare isotopes into the enamel, and the way those isotopes bond depends on the exact temperature of the body that formed them. Tooth enamel is one of the most durable substances biology makes. The chemistry sealed inside it can survive unchanged for tens of thousands of years, which means that from a single ancient tooth, scientists can read the body temperature of a creature that has been dead since the Ice Age. They tested 4 extinct species: Archaeotherium, Megatherium, Nothrotheriops, and a 4th alongside them, each measured against the temperature of the world it had actually lived in. The answer was clear. These giants ran cool, much like their tiny descendants. They were probably less warm-blooded than the typical mammal, and their metabolisms were probably slower too. Not quite as slow as the modern tree sloth, which has refined the trick even further in the safety of the canopy, but slow. Slower than almost anything else of their size walking the earth. So this was the engine beneath the dynasty. Not muscle, not speed. A body that asked the world for less than any of its rivals, and gave back patience in return. It was the foundation everything else was built on, and it let the sloths do something that should have been impossible. Here's what that engine made possible. Growing large is one of the most expensive things an animal can do. A bigger body needs more fuel every hour of every day for a lifetime. For most mammals, that cost acts as a ceiling. But for a creature that already needs less food per kilo than anything around it, the ceiling lifts, and the sloths went straight through it. A study in 2014 measuring fossils across the whole sloth family found they could add roughly 100 kilograms of body mass every million years. That is among the fastest body size growth ever recorded in any mammal. And here is the remarkable part. They did not do it once. They evolved into giants again and again in separate lineages that were not closely related, as though the path to enormous size was a door the sloths alone held the key to. They paired that with a stomach built for hard living. Sloths evolved a great 4-chambered gut, the same basic machine that cows and deer and goats use to break down tough, poor plant food that almost nothing else can digest. Leaves, grass, bark, the wiry vegetation other herbivores starve on. A sloth could turn it into fuel. The same trick appeared, astonishingly, in the sea. Manatees and dugongs evolved their own 4-chambered stomachs to live on seagrass, and the sloths were already most of the way there, which is how they ended up everywhere, in forms that should not have existed. Off the coast of what is now Peru, between 5 and 10 million years ago, there lived a sloth that had walked into the ocean. Slowness. 5 known species, captured in the fossil record across roughly 4 million years, each one a little more committed to the water than the last. Their nostrils crept higher up the snout, the way a diving animal needs them. Their bones grew dense and heavy, ballast to hold them down against the buoyancy of the sea, exactly the adaptation manatees use to graze the bottom. A sloth had become a marine mammal, one careful generation at a time. And while they were colonizing the water, the rest of South America was being torn into a harder shape. The Miocene brought a long planetary cooling, and worse, it raised the Andes. The mountains had been forming for ages, but now they heaved upward fast, and a flat, warm, tropical continent buckled into something dry and mountainous and far less forgiving. For most animals, this was a slow catastrophe, the ground shifting beneath them faster than they could change. The sloths simply changed with it. They threw off new forms to fill the new world, desert sloths and plains sloths and forest sloths, evolving into each opening empire almost as fast as the openings appeared. This was a lineage that did not merely survive upheaval, it fed on it. Every time the world broke and reassembled itself, the sloths were among the first to claim the pieces. Slowness had not made them fragile. It had made them the most adaptable large mammals on the continent. And that adaptability was about to carry them somewhere no one expected a South American animal to go. To understand how far they traveled, you have to understand how old they were. Sloths belong to one of the strangest and most ancient branches of the mammal family tree, a group called the Xenarthra. The name means strange joints, and it is earned. Sloths, anteaters, and armadillos all carry extra articulations in their lower spine, reinforcements no other mammal has, most likely evolved long ago to brace the body for digging and for rearing up on the hind legs. They are an old South American line, and their oddness runs all the way to the bone. Now look at who their closest living relatives are, because the answer makes no obvious sense. It is not the rats, the bats, the cats, the primates, the great mass of mammals that make up 9 in every 10 species alive today. The sloth's nearest kin are a small, scattered group called the Afrotheria. Elephants, manatees, aardvarks, animals of Africa. 2 tiny, niche lineages, marooned on opposite sides of the planet, and yet bound together by blood. The explanation is written in the movement of the continents themselves. Genetic studies place the split between these 2 groups somewhere around 90 to 105 million years ago. And that is almost exactly when South America and Africa, once joined as a single landmass, broke apart and began drifting toward the seas we know today. The ocean opened between them. One lineage was carried east to evolve in Africa into elephants and their kin. The other was carried west to become, in the long isolation of South America, the armadillos and the anteaters and the sloths. They were never strangers. They were families separated by a widening sea 100 million years ago. A line this old does not simply endure, it conquers. And the sloths did exactly that. They did not stay penned inside the continent of their birth. They spread north, eventually establishing themselves across North America, with the remains of at least 11 distinct species found there. But the most telling story is not the ones that crossed over. It is the ones that were already waiting. Take Megalonyx, a great ground sloth whose bones turn up across North America. For a long time, the assumption was that it had wandered up from the south. The DNA says otherwise. Megalonyx did not migrate into North America. It evolved there. Its ancestors had arrived around 9 million years ago, long before any land bridge connected the two continents, when Central America was still a broken chain of volcanic islands rising out of the sea. Somehow, those early sloths crossed that water, island by island, and made the northern continent their own ages before the door between the worlds had even opened. They had done the same in the Caribbean as early as 35 million years ago, seeding the islands with their own peculiar species. Wherever there was water, the sloths found a way across it. Wherever there was land, they found a way to live on it. So by the height of the Ice Age, this was not a fading relic of an older world. This was a triumphant lineage at its peak, spread across two continents, still producing the largest sloths that had ever lived. Which is what makes the question that comes next so hard to answer. What brings down something this unstoppable? For a long time, there was a comfortable answer to that question, and it pointed at the sky. Around 15,000 years ago, at the close of the last great glacial period, the ground sloths began to falter, and by roughly 10,000 years ago, on the mainlands of both continents, they were gone. The timing seemed to tell its own story. The Ice Age was ending. The world was warming, the great glaciers retreating, the old cold landscapes breaking apart and rearranging themselves into something new. And so the explanation settled in, tidy and reassuring. The climate changed, and the giant sloths, creatures of a vanished, colder world, could not keep up. They were swept away by a planet remaking itself. It was nobody's fault. It was just the weather. There is only one problem with that story. These animals had seen it all before. Think about what the sloths had already lived through. They had endured the long cooling of the Miocene when global temperatures dropped and the climate turned against them. They had survived the violent rise of the Andes, which tore their tropical continent into something dry and mountainous and hostile. And the Ice Age itself was not a single event, but a long series of them, glaciers advancing and retreating again and again over hundreds of thousands of years. The sloths had ridden through every one of those upheavals. They had not merely clung on, they had grown larger. The biggest sloths that ever lived were products of the Ice Age, not casualties of it. A lineage that answers each crisis by getting bigger and more diverse is not a lineage waiting to be killed by a warm spell. There is more that does not fit. For decades, the decline of South America's strange native animals was blamed on invasion. When Central America finally joined the continents, the story went, northern predators and grazers poured south and outcompeted the locals. But more careful study has overturned that picture. South America's native fauna were already in decline before the land bridge fully formed. The collapse had begun for reasons that had nothing to do with newcomers from the north, and through it, conspicuously, the sloths held on. They were among the survivors, not the victims. Whatever was thinning the ranks of the continent's other animals, it was not finishing the sloths. So the climate explanation runs into a wall built from the animals' own history. To accept that warming alone destroyed them, you have to ignore everything they had already overcome. You have to believe that the most adaptable large mammals in the hemisphere, the ones who grew giant in the teeth of the ice, the ones who crossed oceans and colonized continents, were undone by a change milder than a dozen they had already shrugged off. It is honest to say the climate may have played some part, and the debate is not entirely closed. But as the whole answer, it simply does not hold. Which forces a harder question. If the thing that killed the giant sloths was not the changing world they had already mastered, then what was it? The answer arrives at the same moment everywhere the sloths died, and it walks upright on two legs. Look at when the sloths died, and a pattern appears that the climate could never explain. They did not all vanish at once. They vanished in sequence, and the sequence follows a single moving thing across the map: the arrival of human beings. The evidence is on the bones themselves. Across both North and South America, ground sloth remains carry the marks of hunting and of butchery, the cuts of stone tools where flesh was taken from the body, and in one place, the hunt itself was preserved. At White Sands in New Mexico, a set of footprints lies frozen in ancient ground. The great clawed tracks of a Harlan's ground sloth, a creature that stood some 3 meters tall, and threaded right through them the prints of people. The trackway tells a story you can almost watch unfold. The sloth turning, wheeling in tight circles, swinging its bulk to keep the humans in front of it. They were stalking it. It was trying to fend them off. A single terrible moment, pressed into the mud and held for thousands of years. Then there is the timing, and the timing is the thing that closes the case. The sloths of North America disappeared first. The sloths of South America followed them, roughly 500 to 1,000 years later, exactly the lag you would expect as human populations spread southward, down the continents, reaching one region and then the next. And the very last ground sloths of all did not live on either mainland. They lived on the islands of the Caribbean, on creatures like Megalochnus, and they survived thousands of years longer than their relatives, holding on until perhaps 4,000 or 5,000 years ago. The reason is simple and damning. Human beings did not reach those islands until much later. Wherever people arrived, the sloths ended. Wherever people were delayed, the sloths endured. The clock of their extinction was not set by the weather. It was set by us. And here's the cruel turn at the heart of it. The very thing that had made the giant sloths unstoppable was the thing that doomed them. For tens of millions of years, slowness had been their genius. It let them eat less, grow huge, ride out every catastrophe the planet could invent. They had never needed speed because nothing in their world had ever required them to flee. They were enormous, armored in muscle and hide and patient. Against a saber-toothed cat, against the cold, against a continent tearing itself apart, that patience had always been enough. It was not enough against a human with a spear. A slow, deliberate, energy-saving animal is precisely the wrong animal to be when the new predator can strike from a distance and simply wait. Everything that had carried the sloths through every prior age made them perfect targets in this one. Their greatest asset had become the thing that killed them. It is fair to say some shifting climate may have leaned on them too, and that argument is not finished. But the signal in the bones, and in the timing, and in the footprints points in one direction. The giant sloths did not lose to a changing world. They lost to a new kind of hunter, one they had no defense against, because they had never needed one before. So return to the tunnel beneath northern Brazil. 1,500 meters of it, branching through the earth, the claw marks still raked into the walls where something the size of a hippo carved its way through solid ground. For a long time, we read those empty burrows as the relics of a failure, the leavings of slow, doomed creatures who could not keep pace with the changing world. They were nothing of the kind. They were the monuments of one of the most successful lineages the Americas ever produced. Tens of millions of years, 2 continents, every ecosystem the hemisphere could offer, giants the weight of elephants, engineers who tunneled through stone. They did not lose to the cold. They lost to something new. And the one gift that had saved them through every age was the one thing it could not save them from. The tunnels remain. The architects are gone. The only thing that had changed was us. If this story stayed with you, subscribe and turn on notifications. We cover the cases history got wrong.